Good evening, friends. Today we are discussing one more problem on velocity and acceleration in the fluid kinematics. Here it is said that the following equations represents two velocity components. There are two cases given here. So in case one, there will be given two velocity components u and v, and in the second case, the velocity components v and w are given. So it is asked to determine the third velocity component such that they satisfy the continuity equation. So in the first case, u and v are given. The third one, that is w, to be found out. Here in the second case, v and w are given, u to be found out. So the solution goes like this. First, we have to write the continuity equation, because in the statement it is said that they satisfy the continuity equation. So the continuity equation is del u by del x plus del v by del y plus del w by del z is equal to 0. Then we are taking the case 1, so in which the two velocity components u and v are given. So we are differentiating u with respect to x, that is the velocity component in x direction. So we have 2x. Here I don't have x in these two parts, so I have only 2x here. Similarly, when you differentiate v with respect to y, so we have y in all the three parts here, so we are getting a del v by del y like this. So substituting this del u by del x and del v by del y in continuity equation, so this is del u by del x, this is del v by del y. We are having some equations here, but del w by del z, there is no velocity component given in the equation. So we are writing del w by del z as it is. So this is equal to 0. So my del w by del z equation will be this. That is rearranging the terms, taking these things on the other side. So then del z will be taken to the other side. So integrating that del w, so we are getting w here. So we have a constant of integration also. But the constant of integration here, it cannot be represented as the function of z, because in the first case, so only the two velocity components u and v in the direction of x and y are given, but there is no velocity component in the z direction. Sorry. So we cannot write this constant of integration as the function of z, but we can write that constant of integration as f of x comma y. Similarly, the second case will be taken where the velocity components v and w are given, u, the velocity component in x direction, that is u, to be found out. Now differentiating v with respect to y and differentiating w with respect to z, will have this del v by del y and del w by del z. So substituting these two in continuity equation, so you have del u by del x, that to be found out. So we have del v by del y and del w by del z. We are getting here the equation for del u by del x. Then we have taken this del x to the other side. So here also, so it will be the constant of integration cannot be in the direction of x, because the velocity component in x direction u was not mentioned in the problem. So the constant of integration will be written as the function of y and z. So this is the my velocity component u in x direction. Thank you.